Hello class, on this video we're going to solve a sample problem, no, the using three moment equations, no. So on this specific video we're going to focus on beams without any fixed support, no, without any fixed end, no. On the next video naman, we're going to focus on beams with fixed end, no. Okay, so before you uh, before you try to solve, no, let me remind you, no, let me give you a tip, no, para hindi kayo malito, no. Kindly balikan nyo yung topic natin on method of consistent deformation that specifically dun sa part na uh, internal forces or movement as redundant, no. So anyway, let's solve this problem. So consider this problem, no. You're given a continuous beam, no, with two simple supports, no, at points A and D, both ends, and then two internal supports at points B and C, no, subjected to a uniformly distributed load of 30 kilonewton per meter, no, on throughout the beam, no. So you are to determine the reactions, no, determine the reactions, no, assuming EI is constant. Okay, no. So let's go back first to the general formula for three moment equations, no. So general formula, no, if you're going to memorize a formula, no, you would rather suggest na you memorize the general formula rather than the others, no, kasi mas madali lang i-derive yung iba pang formula kapag alam mo yung general formula ng three moment equations natin. So MA no, times L1 over E1 I1 plus 2MB times L1 over E1 I1 plus L2 over E2 I2 plus MC times L2 over E2 I2, no, plus 6A1, no, first moment of area 1 over L1 E1 I1 plus 6A2B over L2 E2 I2 is equal to 6 multiplied by H1 over L1 plus H2 over L2. Okay, no. So maya we're going to choose, no, what are the points, no, ano yung mga points na gagamitin natin in forming working equations, no, to solve for your reaction, no. Pero the principle ang principle naman yan, no, is you will have to solve for the internal moments first no? If you are able to solve for the internal moment, no? Masosolve nyo na yung reaction. No? So, ang una natin gagawin, pipili muna tayo ng 3 points na kung saan magbubuo tayo ng equation. No? So, you have to remember, the 3 points should be, yung 3 points na pipiliin natin should be yung mga supports. And of course, dapat yung 3 points na yon magkakatabi. Okay? So, like this one, no, we can do an equation for points A, B, and C, and B, C, and D. Okay? So let's do the equation first, no? So dito, no, we have a derived formula here. We have the general formula here, but let's apply the principles that we have based on the given. No, so based on the given, no, our EI is constant. No, so E1 is equal to E2, I1 is equal to I2. Next, no, they are all supports, no, so therefore no deflection will occur on each of them, no, except, no, kung meron tayong support settlement, no, or any fabrication errors, no, pero we are going to neglect that, no. So therefore, dahil support ito, no, all deflections will be equal to 0. No, so therefore, H1 is equal to 0, H2 is equal to 0. No, so E1 is equal to E2, no, I1 is equal to I2, no, and H1 is equal to H2 is equal to 0. So therefore, ang formula natin will be M1 times L1 plus 2MB multiplied by L1 plus L2 plus MC times L2 plus 6A1 A over L1 plus 6A2 B over L2 is equal to 0. Okay, that is our new 3-moment equation, no, based on our given condition, no. So let's form now our working equations, no, based on this formula that we are able to derive, no. So 3-moment equations for points A, B, and C. Okay, so 3-moment equation for points A, B, and C, no. So M1 L1, no, so M1 L1, M1 times 10 plus 2, no, rather MA times 10 plus 2MB times 10 plus 10 plus MC times 10 plus 6A1A over 10 plus 6A2B over 10 is equal to 0. No, we have now your 3-moment equation for points A, B, and C. Next, we're going to form 3-moment equations for points B, C, and D. Okay, no, so moment at B times 10 plus 2MC rather times 10 plus 10 plus MD times 10 again plus 6. No, so para hindi tayo malito dito, so let's say this is just AB. And this is just BC. Okay? So, area AB, area BC. Okay? So, 6 area BC, no, times A over 10 plus 6 area CD times B over 10. No? It's equal to 0. You have to remember for when computing the first moment of area, yung A, no, shall be measured from the left and B measured from the right. Okay? No? So we already have your 3 moment equations, no? But wait, there's more, no? Based on our given, we have a this is they are all simply supported, no? So simply supported ang A tsaka D natin, yung magkabilang dulo. So of course, we are able to know that your moment at A is equal to 0. No? So, 0 na yung moment at A mo. And yung moment at D natin is also equal to 0. So, therefore, no, we are able to derive that, no, this is 20, no, this is 20 times 2, 40 MB, no, plus 10 M sub C plus 6 over 10, no, area AB A plus 6 over 10 area BC times B is equal to 0. No? Next, we have now your 10 MB plus 40 MC plus 6 over 10 area BC times A plus 6 over 10 area CD times B is equal to 0. So, again, ano ba itong mga area AB, area BC, and area CD na to? No? So, this is the first moment of area, no, of our span, no, of our spans kapag tinanggal natin yung mga internal moment. No? So, we've learned this principle from method of consistent deformation, no, kapag kinonsider nating redundant yung internal moment at saka internal forces, no, kapag kunyari naglagay tayo ng internal hinge dito, so therefore pwede na nating siyang paghiwa-hiwalayin like simply supported beams, no. So ganun ang gagawin natin, no. So we separate each span, no? So this is now your span AB, span A, span B, no. So and then span B, span C. Span C and span D. No, so they are all 10 meters, 10 meters, 10 meters. Okay? Okay, they are all 30 kilonewton per meter. 30 kilonewton per meter. And also 30 kilonewton per meter, no? Okay, and they are all like simply supported beams, no? Okay, no? Again, no? Dahil ang hinahanap natin dito is the first moment of area of the moment diagram, assuming they are all simply supported beam, no, we need to make sure na pag magi-sketch tayo ng moment diagram, no, de ang kailangan nating masigurado madali nating mako-compute yung area multiplied by the centroid, no. So ang gagawin natin, no, we can do, no, yung tinatawag nating by parts. So I made a mistake before, so I am just going to reshoot this part, no. So let me erase this one, no. So this one, this one, this one, and also this, as well as this, no. So we first determine all the reactions, no, assuming that we remove all the internal moments, no. So assuming that they are all simply supported beam, no. So that is equal to 30 multiplied by 10, no, divided by 5. Okay, rather 30 times 10, no, divided by 30 times 10 times 5, no. Okay, divided by, I'm going to so summation of moment at A, no, so it's equal to 30 times 10 times 5 minus x times 10 is equal to 0. So this is equal to 150. This is equal to 150. 150, 150, 150, 150. Okay, next, no? So we are to sketch the moment diagram of each span, no? But they are, since these are all they are all undergoing the same load, no, we can assume that one moment diagram fits all, no. So bakit, no? Kasi, no, we are to compute, no, we are to compute yung first moment of area, no, of the moment diagram, no, of this span, no. And we should make sure na madali lang computein yung area nyo tsaka yung centroid. So therefore I decided to do by parts here, no. So due to the 150 kilonewton reaction, 150 times 10, no, this is equal to 1,500, no. So this is 1,500. Okay, and due to the uniformly distributed load at point A, this is also equal to 1,500, but negative. Also on span CD, no, since from the right yung measurement ng centroid, no, ganon din ang ginawa kong moment diagram by parts, no. So this one, they are just the same, no. So we are able to know na all first moment of area are just the same, no. Okay, so therefore computing AAB multiplied by A, no, is equal to 1/2, no, the area of the triangle, no, 1/2 times 1,500 times 10 times 10 over 3, okay, minus 1/3, no, this is a second degree curve, no, times 1,500 times 10 times 10 over 4. that is equal to 12,500, no? Okay, no? And yung area AB times A is equal to area BC times B, area BC times A, and area CD times B. Okay, no? So 12,500, no? We just multiply this by 6/10. Okay, that is equal to 7,500, no? So now going back here, going back, uh, no? So we already have your first moment of area, no? Which is also equal to area times B, no? Balik tayo doon sa working equations natin, no? Itong dalawa. Okay? So 40 MB, no? 40 MB 40 MB plus 10 MC plus 6/10 times 12,500 negative plus negative 12,500 negative 12,500. Okay, no? So that will be 40 MB plus 10 MC plus 6/10 times 12,500 minus plus 6/10 times negative 12,500, no? So plus negative 15,000 equal to 0. 10 moment at B plus 40 moment at C, they are all just the same, no? So plus negative 15,000 is equal to 0. So we use mode 5.1 here, no? Pero as far as I know, no, the calculator that I'm using is already prohibited by the Board of Civil Engineering, no? So you have to find your way. Are we going to solve two equations and two unknowns, no? So 40, 10, 15,000, no? All the constants should be transferred on the other side. 10, 40, 15,000, no? M moment at B, no, and moment at C are both equal to 300 kilonewton meter. 300 kilonewton meter. Okay, they are both positive, no? And our assumption, no? So they are both positive, no? So ang sign convention natin, they are both making the beam smile, no? Okay, no? So we have your internal moments already, no? Let's solve for the reaction, no? Okay, I'm going to redraw this figure, no? So AB, BC, and CD. AB, no? So AB, A, B. No? So you can either, kasi syempre hindi na natin we don't have to use summation of forces or summation of moment na, no, equal to 0 dahil baka malito lang tayo, no, and the process will be much longer than the usual, no? So we just use what we call the principle of superposition, no? Okay, I should delete this. Okay, 10 meters, 10 meters, 10 meters. So I decided to sketch this again, no? Kasi we are going to use what we call the principle of superposition, no? So from the principle of superposition, no, from method of consistent deformation, no, concerning internal moments as redundance, yung ginawa natin, no, we assume that every span are single supported beam, no? So ngayon, we remove all the loads, no? This is 30 kilonewton per meter. 30 kilonewton per meter and 30 kilonewton per meter, no? We remove all of them, and we put now all the internal moment that we have solved, no? No, so this is A, this is B, B, C, C, D. Okay, no? No? So first, no, all the reactions, no, all the reactions due to uh, lahat ng reaction natin, because this is a these are all assumed to be simply supported beam, no? This is 150, no, this is 150, this is 150, this is 150, 150, 150. Okay, next, no? So you have to take note that this point, no, this reaction, this 150 upward, no, is the shear at point B, no? So this is upward here, no? So we can say that this is downward, no, near the support, no? So this is 150, no, and this is upward here, therefore this is also downward on the support. Upward, downward, upward, downward. Okay, no? So yan na. Okay, no, and these are both downward. We can say that this is 150, 150, this is 300. 150, 150, this is 300. Okay, no? So next, no, we are going to put now the internal moments that we've solved, yung dalawang 300, no? So this is 300, no? So this is 300, so this is 300, this is 300, 300, 300, 300, 300, 300, 300. Okay, no? So now we determine, no, all the reactions due to the internal moment, no? At span AB, ang reaction natin due to the internal moment of 300, no? Since this is a counterclockwise moment, no, we will counter it. No? So kokontrahin siya ng clockwise moment. So therefore, if at point A, no, the reaction will be clockwise, no? So upward. Next, dahil upward ng force natin at A, no, we can say that your force at B is also downward, no? So 300, no, 300 divided by 10, which is equal to 30, no? Ang ginawa ko kaya naging 30 yan, no, let's say that is just summation of moment at B, no? ang no, at span AB lang, at span AB. No, so 30, no, 30. Okay? No? 30. This is 30 downward, no? So therefore I can therefore conclude that we have 30 upward here. No? So okay? 30 downward. Next again here, no? So we have a clockwise movement. We have a clockwise movement here, no? So ang kokontra sa kanya is counterclockwise. So therefore at point D, that is also upward, no? So this is equal to 300 again divided by 10, 30. This is equal to 30, no? And then 30. Okay? No? So how about here, no? Kamusta at span BC, no? Since at span BC, since we have both uh, 300 kilonewton meter moment, no? We can say that no? So since this is 300 kilonewton meter moment. So if we isolate your span BC, no? So 300 kilonewton meter, no? Plus 300 kilonewton meter. 300 kilonewton meter clockwise movement minus 300 kilonewton meter counterclockwise, no? Okay, no? So yeah. No, so 300 kilonewton clockwise minus 300 kilonewton counterclockwise, no? So 300 minus 300, no? Okay, plus x times 10 is equal to 0. Okay, no? So we don't have any reactions here. Due to the internal moment. So therefore this is also equal, this will be equal to 0. This is equal to 0, no? So kung may 30 tayong upward, no, we can say that this is 30 downward, this is 30 downward also. Okay, so we add all the reactions now, no? So 150, no? So starting from point A, okay, no? So now we combine all of the reactions now, no? So we have 150 plus 30, both upward kasi, no? So therefore this is equal to 180, no? Now next we have 300 upward, no? We have 300 upward minus 30, no? This is equal to 260, rather 270, no? And then we have 300 upward and then 30 downward, no? This is equal to 270. And then we have a 150 plus 30, this is also equal to 180 kilonewton, no? So these are now your reactions, no? You can check that, no? You can check by doing summation of forces upward is equal to 0. 180 plus 270 plus 270 plus 180 minus 30 times 3 times 30. That is equal to 0. So therefore, all our reactions are correct. No? Okay. So that ends our video. No, we're on the next video. We're going to conclude three-moment equations by solving another problem. No, on that video naman, we're going to solve problem na concerning fixed supports. No, for any questions, continue. You don't hesitate again to leave your comments below. And for more updates, no, kindly like and subscribe to this channel, no, or always check your Blackboard, no. Okay? So see you on the next video.